Okay, this is about the idea of the tangent as a function, and I'm going to work in Desmos to make this work. If you really simply just graph y is equal to the tangent of x, you get a graph that looks like this, and it has this strange form to it. Part of the logic behind this is having to deal with the sine and the cosine. And what I want to show here is that the tangent graph is going to have an asymptote at every pi over 2 units. So like let's draw in an asymptote here at x equals pi over 2. There's one there. Let's put another one at x equals negative pi over 2, and you can see that like there's an asymptote there, that like it is very clear that this function that's making a period every pi units, because the distance between negative pi over 2 and pi over 2 is pi, so it's repeating itself every pi units, is never going to hit negative pi over 2 or pi over 2 or 2 pi over 2 or 3 pi over 2. It's never going to hit those spots. Okay, so why is it never going to hit them? Well, recall, like if I take y equals the sine of x over the cosine of x, this is exactly the tangent of x. So like the purple one that I just drew is right on top of the red one. Now remember that, let's get the graph of the cosine of x up there, right? So y equals the cosine of x. The denominator here is the cosine of x. Now look at where the cosine of x is equal to 0. Here, here, boom, right at the green asymptote, right at the blue asymptote. Every time the cosine of x is 0, the tangent, which is the ratio of the sine to the cosine, is not going to exist because you're going to be dividing by 0 there. Every time that the sine is 0, so let's look at the sine of x. Every time the sine is 0, the tangent is also 0 because the sine is up top. It's in the numerator, right? So every time the sine of x is 0, the tangent is also 0. So this is, let's get rid of these guys. This is our tangent curve. So let's get rid of everything but the tangent and those couple of asymptotes there. And this is what it looks like. And you can play around with parameters with this, just like you can with the sine and cosine. You'll get that vertical stretch using the A. You'll get the change in periods using the B. The vertical shift using the C, and the horizontal shift using the D in the standard form of the function. All right, so there you go. That's a basic overview of the tangent function in the plane. All right, thank you.